Welcome to Creative World. In this video, we will solve Chapter 3 exercise problem number 3.13. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 3.13. Use nodal analysis to find the value of voltage V0 in given below figure. This is the circuit diagram of given problem. Inside this network we have to find the value of voltage V0 across this 1 kilo ohm resistance, and we have to use nodal analysis technique. So without wasting time, let's proceed towards the solution of the network. We know that in order to apply nodal analysis on any network, we have to follow some steps. First step includes finding out the maximum number of node voltage equations that can be retrieved from that network. So using this equation, we can find the value of that figure. In this equation, n represents the number of nodes exist in the network. So in our case, there are 4 number of nodes. 4 minus 1 will be equal to 3. Here is the mistake. This number is 4. So 4 minus 1 will be equal to 3. In next step, we have to label all unknown non-reference node voltage. So these 3 node voltage are labeled as V1, V2 and V0. We have taken this node voltage as V0 because this voltage is appearing across this 1 kilo ohm resistance and we are interested to find their value. So whatever the value of this node voltage will be, that voltage will also be appearing across this 1 kilo ohm resistance as well, because this is reference or ground node. In third step, we have to assume all unknown branch currents along with their directions in the network. Now we will apply one by one Kirchoff's current law on these 3 nodes to find out their respective voltage equations. We will start from here. On this node, one current is entering I2 while 2 currents are leaving I5 and I1. Entering current is taken with positive sign while leaving currents are taken with negative sign. In next step, we have to replace all these 3 currents with their respective equations. Current I2 will be equal to V0 minus V1 divided by 1 kilo ohm. Here this resistance is connected between 2 non-reference nodes and current through this resistance is labeled as I2. So current through this resistance will be equal to voltage across this resistance divided by the value of resistance, and voltage across this resistance will be equal to the difference of these 2 node voltage. Now the direction of current I2 is from this node to this node, which is indicating that voltage V0 is on higher potential than V1. That's why we have taken the difference of these 2 node voltages as V0 minus V1. Current I5 will be equal to V1 divided by 1 kilo ohm and current I1 will be equal to V1 minus V2 divided by 2 kilo ohm. Again, this resistance is connected between 2 non-reference nodes and the direction of current I1 is from node 1 to node 2. That's why we have subtracted this node voltage from V1. Here this node voltage is already given in the form of voltage source. So V2 will be equal to 12 volt. That's why we have subtracted 12 volt from V1 and divided by 2 kilo ohm to find out current through this branch. Now multiply this equation on both sides with 2 kilo ohm. Product of 2 kilo ohm and 1 kilo ohm in denominator will cancel out with each other. Only 2 will left and that 2 will multiply with V0 minus V1. Here product of 2 kilo ohm and 1 kilo ohm in denominator will cancel out with each other. Only 2 will left and that 2 will multiply with V1. It will become 2V1. Here product of 2 kilo ohm and 2 kilo ohm in denominator will cancel out with each other. Only V1 minus 12 volt will left. Now open these brackets. The equation will become 2V0 minus 2V1 minus 2V1 minus V1 plus 12 volt. Place this 12 volt on the other hand side of equal and add values having variable v1 together, the equation will become 2v0 minus 5v1 equal to minus 12 volt. We cannot further solve this equation, so leave it for now and label it as equation A. It is the first node voltage equation of this network. Now we will apply Kirchoff's current law on this node. On this node, all currents are leaving, no current is entering. So all leaving currents will be taken with negative sign, and leaving currents are I2, I4 and I3. Next, we have to replace these currents with their respective equations. Current I2 is equal to V0 minus V1 divided by 1 kilo ohm as we have calculated in previous step. Current I4 is equal to V0 divided by 1 kilo ohm, while current I3 will be equal to V0 minus V2 divided by 2 kilo ohm. Now multiply this equation on both sides with 2 kilo ohm. Product of 2 kilo ohm and 1 kilo ohm in denominator will cancel out with each other. Only 2 will left, and that 2 will multiply with V0 minus V1. Here product of 2 kilo ohm will cancel out with 1 kilo ohm in denominator. Only 2V0 will left. Here product of 2 kilo ohm and 2 kilo ohm in denominator will cancel out with each other. Only V0 minus 12 volt will left. Now open these brackets. The equation will become minus 2V0 plus 2V1 minus 2V0 minus V0 plus 12 volt. Place this 12 volt on the other hand side of equal and add values having V0 variable together. The equation will become minus 5V0 plus 2V1 equal to minus 12 volt. We will leave this equation for now and label it as equation B. It is the second node voltage equation of this network. We don't have to apply Kirchoff's current law on this node because the voltage of this node is already known, which is 12 volt. So now we will try to solve these two equations to find out the value of voltage V0. For that purpose, we will multiply this equation A with 2. The equation will become 4V0 minus 10V1 equal to minus 24 volt. And we'll multiply this equation B with 5. This will become minus 25V0 plus 10V1 equal to minus 60 volt. Add these resulting equations together. Minus 10V1 and plus 10V1 will cancel out with each other. Sum of 4V0 and minus 25V0 will become minus 21V0. And on the other hand side of equal, sum of minus 24 volt and minus 60 volt will become minus 84 volt. Now divide on both sides with minus 21 to calculate the value of voltage V0, that will become 4 volt. So the value of voltage across this 1 kilo ohm resistance in this network is 4 volt. This was all about chapter 3 exercise problem number 3.13. Thank you. See you again in next video.